What's up, you guys? In this one, we're going to be talking about stretching the function. So in the last video, we talked about moving it up, down, left, right, all those things. Now we're going to actually start multiplying our function. So the same rules are going to apply. If we're multiplying inside with the x, we do the opposite of what we see. If we're multiplying outside of our function with the y, we do exactly what we see. So let's kind of see how that works. So with this first one, words, can't talk. We have an x squared. So again, I'm still thinking about my quadratic parent function. So I know I have something-ish like that. So now what this -2 does, this -2, notice it's not really in the parentheses with that squared. So what I'm going to do is I'm going to multiply all of my y values by -2. So what this is also going to do, so notice this y value is 0. 0 times -2 is 0. This y value is 1. 1 times -2 is -2. Now notice I keep the x value the exact same. I'm only multiplying the y values. This y value of 4 is going to multiply by -2 to make -8. So it goes all the way down there. So notice again, the x value stayed the same. It's still on 2, but the y value becomes -8. So same thing on the other side. 1 times -2 is -2. 4 times -2 is -8. So what happens to my parabola is that it's called a reflection over the x-axis because it's like it mirror imaged itself over the x-axis and it vertically stretched by a factor of 2 because I'm multiplying my y's by 2, so they're stretching by 2. They're getting much longer. So reflection over the x-axis and vertical vertical stretch by a factor of 2. All right, now for the domain range, -infinity to infinity. And notice the range, since we did a reflection, it's now going from -infinity all the way up until 0, where 0 is included. So it's still hitting at 0, so it's everything down below 0. All right, moving on. So here, same idea. Notice though, this is a 1/2. So what's going to happen is I'm going to multiply my y values by 1/2, so it's going to vertically compress or shrink it by a factor of 1/2. There's no negative, so there is no reflections. It's still a parabola because I still have a squared, so I have something like that. Now if I take my points and I multiply all of my y values by 1/2, still 0 times 1/2 is 0, so that stays. 1 times 1/2 is 1/2, so that kind of breaks half of the distance. Same thing on this side. 4 times 1/2 is 2, so that goes to there. So what happens is it kind of stretches my parabola out, and it makes it wider. It compresses it by a factor of 1/2 in the vertical direction. It shrinks it vertically by a factor of 1/2. Those are all the ways that I think you can see it. I'm not even worried about the domain and range on this. We've been doing it the whole time. All right. So now this next one, notice, now I have something inside with the x. So notice here how my x's are being divided by 2. What I'm actually going to do though is multiply by a factor of 2 in the x direction. Remember, with your x, do the opposite of what you see. So first I'll put my cubic parent function on here. So I have my cubic parent function right there. Right, we have something like this. Right, there's our cubic parent. So now, again, like I said, the x is being divided by 2 right now, so the opposite thing would be to multiply by 2. So I'm going to multiply by x's by a factor of 2, and it's going to stretch them out. It's going to horizontally, since it's horizontal is the x direction, horizontally stretch by a factor of 2. So I'm going to take all of my x values, multiply by 2. My y values are going to stay the same this time. So my x value here is 0 times 2 is 0. X value is 1 times 2 is 2. X value of 2 times 2 is 4. X value of -1 times 2 is -2. X value of -2 times 2 is -4. So notice the y value stayed the same, but it stretched out in the x direction, like so. All right, so then domain and range. It's going left and right forever, so -infinity to infinity. The range also going up and down forever, so -infinity to infinity there. All right. So with D here, notice I'm multiplying my x's by a -2. So when I do the opposite, I don't change the sign. Instead of multiplying by 2, though, I'm going to divide my x's by 2. So this negative inside, I'm going to keep that and multiply my x's by a factor of -1/2. I keep the negative, but instead of multiplying by 2, I'm going to divide by 2. So I'm going to go ahead and put my cubic parent on there again. Cubic parent. All right. So now x is by -1/2. So x 0 times -1/2 stays. 1 times -1/2 actually flips to the other side, right? Because it's now 1 becomes -1/2. 2 times -1/2 becomes -1, so that moves there. -1 times -1/2 is 1/2. -2 times -1/2 is +1. So what happens is it reflects it over the y-axis, and it horizontally compresses by a factor of 1/2. That's pretty much it. Domain range is going to stay the same as the last one. Still going out forever, and it's going up and down forever. All right, so now we're going to start getting into ones where it's actually moving as well as stretching and shrinking. So with this one, first thing I notice is I have a cube root. So I'll go ahead and put my cube root parent function. Right, so there's my cube root parent. So now there's 2 on the outside, and when we are moving around functions, we still have to follow the order of operations. So we're going to multiply and divide before we add or subtract. So I need to stretch or shrink before I actually move that stretch or shrink around. So I'm going to multiply my y values by 2 first. So 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. Same thing in this direction. -1 times 2 is -2. -2 times 2 is -4. So now what I'm going to do with those points, because this is just when I stretch it by a factor of 2, right? So that's just stretching my graph, multiplying the y's by 2. Now this -4, don't forget if it's inside with the x, it does the opposite. So this takes all of it and moves it to the right 4. So right 1, 2, 3, 4, right 4, here we go there. Right 4 is off the graph, right 4, and right 4. So now I have my final graph here in the green with all of my stretches and moving, all of that happening. So now for the domain and range, we'll do it on this one. It's going left and right forever, so -infinity to infinity, and the range is also going up and down forever, so still -infinity to infinity. There's no breaks in those graphs. All right, moving on, we got 2 more, and then we're done with Unit 4. Then you can take the test. Make sure you guys turn in your review online or email it to me, and that way I can mark you down for those grades. All right, so the first thing I notice is I have a squared, so I have a quadratic. So I'm going to go ahead and put my quadratic parent function on here. And if it helps you, it helps me to keep track of what I need to do. So something I like to do is it's called Mrs. Backwards because I like to stretch and then reflect and then move. These first 2 kind of go together. So this is just our multiplications. And then I'll do any moves. So with the stretch and reflect, I notice I have a -3 on the outside. So I'm going to do y's by -3. Right? It's not with the x. And then I have a left 4, so I'm going to do the opposite, and a up 1, because it's on the outside, it's not with the x. So if I just multiply my y's by -3, 0 times -3 stays, 1 times -3 is right here, 1 times -3 is -3, 4 times -3 is -12, so that's all the way down there. Likewise, it mirrors on the other side since it has y-axis symmetry. So here is just after the multiplication in the green. And then I'm going to take everything, move it left 4, so left 4 and up 1. So left 4 and up 1, left 4, up 1, and these points will be all the way down there. So I'll have something going more like this for my parabola. All right, so now the domain and range. So domain, this is opening in both directions. I'm going to assume that this keeps going out and out forever and ever. So -infinity to infinity. And then the range, the very highest y value is 1. And it's everything below that. So I know I'm going from -infinity all the way to +1, where +1 is included because that is my vertex. All right, moving on. So again, keep track of what's going on. First thing I see is it's a squared. So I know it's going to be a parabola. So I'm going to go ahead and put my parent function points on there so that I can go from those. So I'll have a parabola going out from there. All right, so now for the stretch and reflect, and then I'll do my moves. So I notice I have a negative on the outside, so no other multiplication, so I'm just going to do y's by -1. Remember, if I'm taking my y's by -1, that's going to reflect it over the x-axis. And then for the +4 inside here, that means I'm going to move it to the left 4. I have a -3, so I'll move it down 3 units. So y's by -1 reflects it over the x-axis. So I have everything down here. Right, so we have a parabola going like that. And then take everything, move it left 4 and down 3. So 1, 2, 3, 4, and down 3. So I get my new parabolic function. Right, and that's almost like vertex form, where we had a -a, so I know it's opening down, and the vertex should be -4, -3, so -4, -3, so there is my vertex. All right, so now for the domain and the range. So for our domain, it's going left and right forever still, so -infinity to infinity. And then for the range, the very highest value I have here is -3, and it's everything below that. So I'm going from -infinity all the way up until -3, where -3 is included. All right, hopefully this was helpful for you guys. Please, please, please email me with questions. Let me know what I can do to help you out. I always look forward to answering questions, so just please contact me out. We can always set up a Zoom one-on-one session. All right, I'm here for you. All right, bring it on. I'll talk to y'all soon. Bye.